Hi, in today's tutorial, we'll explore ACERetro, a computational tool designed for chemoenzymatic retrosynthesis. ACERetro employs a hybrid search algorithm that efficiently generates chemoenzymatic synthesis rows by combining chemical reaction with enzymatic reactions. Additionally, it evaluates the synthetic potential of molecules. This makes it particularly useful for identifying chemoenzymatic synthesis rows quickly and effectively. Let's first see what is chemoenzymatic retrosynthesis. So it is a strategy that integrates organic chemistry with enzymatic reactions. This enables people to design these hybrid synthesis routes. The process, as shown in the right, involves deconstructing a complex target molecule step by step into a simpler precursors. This can be achieved by either chemical reaction or enzymatic reactions. By combining them together, we can get a better route that we call it chemoenzymatic synthesis route. And the alternative strategy is the bypass approach. So this approach replaces certain parts of a synthetic route with either enzymatic or organic reactions. So in the final result, it will contain both chemical reactions and enzymatic reactions. So apart from that, in ACERetro, we propose using molecule synthetic potential to unify these two strategies. The synthetic potential evaluates which type of reaction is more suitable and promising for a molecule with the SPScore. Specifically, SPScore can guide its selection of precursor and reaction type in step-by-step strategy as shown in the red square. Additionally, it can also be used to heuristically find organic and enzymatic opportunities in a synthetic routes. So before we discuss the asynchronous search algorithm of ACERetro, here I list the previous chemoenzymatic synthesis planning tools that using a synchronous search. In other words, in these algorithms, they search enzymatic and organic reactions in parallel. However, in the ACERetro, with the help of synthetic potential score, the algorithm can prioritize the promising reaction type of a molecule, which means it can either firstly search the organic reaction or the enzymatic reaction based on our evaluation of SPScore. Now, let's look at the web page of ACERetro. So here is the link. After you get this link, you will see the user-friendly UI here. So the UI will input the target molecule either from smells or draw the molecular structure. And after that, you can see here, you can also set the parameters of searching. So the first parameter is the maximum depth of synthetic route. So for a more complex molecule, you may increase this value. And the next is the calculating times. So also the same, if a molecule that need a very long time, so you can increase this value to increase the probability to search that result. And after you finish these two parameters, you can submit the job by inputting your email here and then click the blue button. So here shows the processing web page. So after you wait a couple of minutes, you will get the final results that predicted by ACERetro. So the resulting page includes several parts. The first is the SPScore of this target molecule. The red part describes the SPScore in chemical reactions, and the purple part describes the SPScore in enzymatic reactions. And you can, scrolling down, you will find the filter sections. So this can filter some specific starting molecule or the price of the starting molecule and others. And the next part is the predicted rows. As here, you can see all the rows are listed here. After you click this button, you can check the row details. As here, you can see in the row details, we list all the reaction steps, and also we list the reaction information. For example, for enzymatic reaction, we have the EC number associated with it. And also in the molecules, for each molecule, we list the SPScore calculated by us. So basically, these are all the tutorial for today, and thanks for watching. So if you have any questions, please feel free to contact us or find us in this GitHub page. Thank you so much.